So today I'm going to explain about carbon compounds. Now, the study of carbon compounds is called organic chemistry. But it doesn't include all kinds of carbon compounds. Like oxides, we don't include oxides like carbon dioxide, carbon monoxide. That doesn't come under organic chemistry because their properties are different from organic compounds. And carbonates also, hydrogen carbonates in the sense like sodium carbonate, that doesn't come under organic chemistry. And hydrogen carbonate also will not come under organic chemistry, and even carbides. Now, how does a carbon atom look like? A carbon atom looks like this. There are 2 electrons in the first shell, and there are 4 electrons in the last shell. But we know that according to the octet rule, there should be 8 electrons in the last shell in order to get the noble gas electronic configuration, like neon or helium. Now, in order to get the neon's electronic configuration, we have to make it 8, right? So we have to add 4 more. Otherwise, we can make it as helium by just taking away all the electrons. That's the 4 electrons which we started with. Okay, that means like we have to add 4 electrons or take away 4 electrons. But both cases are not really practical, because if we plus 4 in the sense like we'll give away 4 electrons, and if we give away 4 electrons, that means like that will take a lot of energy. Whereas if we gain 4 electrons, it's not very easy to for 6 protons to hold 10 electrons. So we have to share electrons. Now we'll be going forward and learning the sharing of electrons. That's covalent bonds. So it has to share 4 electrons, and these 4 electrons are shown by 4 bonds. Yeah. So according to the octet rule, we have to get 8 or 2 electrons, but which is not practical as I told you. So, and by the way, the valency of carbon is 4. That means it has to share 4 electrons by covalent bonds, and these bonds are shown by these 4 lines around carbon. Now we'll be moving forward to learn more about this organic chemistry, the covalent bonds and all. So next part of this. So carbon is found in nature in 2 states, the free state and the combined state. Now in the free state, it can be found in diamond, in graphite, and in Buckminster fullerene. Now diamond and graphite is familiar with you. Now diamond and graphite, all these 3 compounds are simply made of only carbon atoms. That's why I called it free state. Whereas combined state is like, you find other atoms with carbon atoms. Now diamond, its property is like it's really strong, it's really hard, but it doesn't conduct electricity. Whereas graphite conducts electricity, but it's really soft. Now just look at the difference. Like both are made of carbon atoms, but their properties are entirely different. And Buckminster fullerene is a newly found compound, and it's made up of 60 carbon atoms. Now I'll be explaining about the combined state. Now carbon, as I told you, like it is found in free state and the combined state. But before I tell about the combined state, I have to explain about the properties by which carbon combines with other atoms. Now there are 2 properties. First we talked about the tetravalency. Now tetravalency we discussed before, right? That is, the carbon atom can join with 4 other atoms, and that's really huge, Now the second property is catenation. Now catenation is like the carbon atom can join with a lot of carbon atoms like this. This means like it will join with more and more carbon atoms. That's why there are millions and millions of carbon atoms in carbon compounds. Like at present itself, the scientists have found out 5 million carbon compounds in the combined state because of these 2 properties. And moreover, one thing is also there. Now the carbon compound, the bonds, is really strong because carbon atom is small, and so its its protons and neutrons can hold the electrons really stronger. Even silicon also shows this catenation property, but as you know, silicon is bigger than carbon, so it will not be able to hold the bonds as strong as carbon. So it's versatile in nature. Why is it called versatile in nature? Because it's tetravalency. I told you what is tetravalency. It's like carbon can join with 4 other atoms, and carbon can have a bond with 4 electrons, so it can share 4 more electrons. Then catenation, it's like makes a long chain of carbon atoms, and accordingly you can join it with hydrogen or something and make the bond full. I mean, make the all 4 bonds filled. Now catenation, tetravalency, I told you, and so it's versatile in nature. That means it can make a lot of compounds. As I told you, we can make 5 million compounds of carbon atoms. Now we'll be explaining organic compounds. Now organic compounds, why is it called organic compounds? Because it's biologically found. Like I am made of carbon. My food materials like grains, pulses, everything is made of carbon. So it's mainly organic compounds. But there are some exceptions, like Friedrich Wöhler. He proved that urea, which was believed to be an organic compound, can be formed synthetically. So this contradicts the fact that organic compounds cannot be made synthetically. So now we will be having an interesting talk of organic compounds and more about it. Thank you for today.